Hello and welcome to another one of D's ADD videos. Today we're going to be looking at another advanced trig integration video. This time we're going to be dealing with tangents and secants. So when we're dealing with tangents and secants, and it's not just a plain u sub problem, where you could let u equal one part and the du is staring at you in the face, you're going to have to do something a little bit more creative. Take some extra steps. So in this case, whenever they're not the same, you might have one of the exponents or both that are greater than 1. One of them might be in the denominator, okay? But there are a few different scenarios that you're going to need to look for whenever you're dealing with these type of problems. And these are the basic scenarios. I'm going to do a separate concept video for each one of these scenarios. In this one, we're going to deal with tangent being odd. So our tangent exponent alone would need to be odd and positive, meaning in the numerator. All right, again, tangent would need to be odd and in the numerator. It can't be negative, it has to be positive. So for each one of these scenarios, we're going to have a different term that's going to be set aside, and we're going to have a different term that's going to be our u. In this case, when tangent is odd, what we're going to be doing is we're going to be pulling out a secant tangent and then converting everything into secants. So we pull out a secant tangent, convert everything into secants. All right? And when we do so, we will end up with a u substitution problem if we did everything correctly, in which u will be your secant. du will be your secant tan. So let's look at an example partially solved to see what's going on. So here, I didn't do anything too complex, nothing fancy. We have a tangent odd, okay? Tangent being odd is rule number 2. So in that rule, I told you to pull out a secant and a tangent. So we would borrow one secant and one tangent from each of these. And when we do so, we would get something that looks like this. Secant squared x, tangent squared x, with a secant x tan x left behind. This term right here, that's going to be your du here in a few steps when you do your u substitution. So if that's my du, well, what would be my u? Well, what do I derive to get a secant tangent? Well, that's a secant. So that would be my u. So anything that's not a secant, like this tan squared, should be converted into a secant using your Pythagorean identity. So if you remember, tan squared x equals secant squared minus 1. If you don't remember, start out with sine squared x plus cosine squared x equals 1 and divide everybody by cosine squared. And then when you do that, solve for tan squared, and you should come up with the same thing. At that point, well, we know we have to convert everything into secants. So let's do that. Let's plug in tangent squared and what it equals in terms of secant. And now what we have is something that could be turned into a u, and the leftovers will be your du that will cancel out. So u would be your secants. You don't even have to distribute first. You can plug in, make that u squared times u squared minus 1. And then depending on how you do your u sub, the secants will cancel out with the secant tan over here. All right? And then at that point, all it is after that is your basic u sub problem. So you follow your u sub rules after that. Okay? Nothing too complex if you know the rules and what to do, right? If I told you to drive in Mexico and you got to head south, it's not too hard. You just start heading south, you'll eventually get there. Probably not the smartest thing to do. A map would be a good idea, right? But this is your map. What to do, one of these 3 scenarios. In this case, tangent was odd. We pulled out a secant tan, converted everything to secants using this identity. All right? That should be enough for you to practice these types of problems where tangent is odd. Secant could have been in the denominator. Don't let that fool you if tangent is odd and positive in the numerator. All right? There are other videos for secant is even and tangent is even. Make sure you check those out. And as always, practice, practice, practice. That's the most important part of all of this until it becomes second nature. Thank you and have a nice day.